I think we were done with case 5. Angle between the lines, were we done with that? Okay, so case 6 is about parallel lines. And okay, so see, if the direction vectors of your two lines, if the direction vectors of the two lines are parallel, then one of the two things may happen. Either the lines would be running separately parallel to each other, just like wave tracks, or they would be overlapping lines. In which case we generally don't call it overlapping lines, we say that both the equations are representing the same line. It's the same line which is being represented by two different equations. So the first thing is the direction vectors of the lines have to be parallel. Otherwise, if the direction vectors are not parallel, the situation is something like this. Then the lines are not parallel at all. But if the direction vectors are parallel, then we have to find out one of the two situations. Now, see, although you say overlapping lines are also parallel lines, but when the examiner says parallel lines in the equation, he would mean lines which are separately running parallel to each other. So you'll have to distinguish between the two cases. In which one case is that the lines are separately running parallel to each other, in the other case is where they are overlapping, in which case we say that both equations are representing the same line. Now, how do we discern that? So this is what I've written over here. Let's take question number 9. And we'll understand the procedure through the question. So see, there are two equations given over here of line L1 and L2, and we have to show that they are parallel lines, which means the examiner is trying to say that you have to show that the lines are like this, parallel to each other, separately. Okay, so see, the very first thing that you need to do is you need to show that the direction vectors are parallel, and that's through showing that the direction vectors are scalar multiples of each other. That should be your first step. So first write the equation down in the proper A plus lambda D form. Let's do that, so that you can identify the direction vectors separately. So I think the first equation is, check, is it something like this? Check, is it something like this? 1 minus 2, 1. And your second equation would be something like this. If you bring it to the A plus lambda D form. There's nothing here means there's a 0 plus lambda I. 0, 3 and 2 are the coordinates of the fixed point, and lambda, 1 lambda, minus 2 lambda and lambda, they become the components for the direction vector. Same case over here. Is everyone comfortable with the A plus lambda D form? Any confusion? Okay, then the next step is show that the two direction vectors are parallel. How do you show two vectors are parallel? The simplest way is they have to be scalar multiples. So it's very obvious over here that minus 2, 4, minus 2 is 2 times minus 2 times 1 minus 2, 1. So clearly they are scalar multiples. Yeah. Therefore, D1 is parallel to D2. नहीं, ये तो भी आपने शो किया कि पैरेलल, बिकॉज लाइंस की सिचुएशन में तो देखेंगे either नॉन पैरेलल और पैरेलल लाइंस. So एक बात तो तय हो गई, they are parallel. But overlapping. अब now we have to distinguish between the two.
So in line 2, like won't carry 1 minus 2 to you.
No, minus 2 multiplied by 1 minus 2 times this minus 2 is equal हो जाएगा. Okay. Now how do you distinguish between the two cases? It's very simple. I'll just give you an example. Let's say these are the two cases. this is line 1 and this is line 2. Line 1 and line 2. एक situation ये है, एक situation ये है where they could be overlapping, or in other words you would say they represent, both the equations are representing the same line. This would be the situation. For the two direction vectors to be parallel, we can have either one of these situations. Now, how do you tell the difference that either this is happening or this case is happening, when this is your line L1 and this is your line L2? Now see, it's very simple to tell. Now, this point right here, this point right here, this is your fixed point on the line L1, right? Let's say this is this point, right here. If these two lines are separate and running parallel to each other, but separate from each other, is it reasonable to say that point A, which is a fixed point on line L1, will not lie on line L2? Okay. Whereas, if this was the situation, where both the equations were representing the same line, then one point, one fixed point on one line would be common to the other line as well. Which means that if this is the case, where both equations are representing the same line, this one fixed point on line L1 also lies on line L2. And you know, it is very easy to show whether a point lies on the line or not. If you remember, we've done that case as well. You have to convert the equation to the parametric form, plug in the coordinates in place of x, y, and z, and show that all lambdas come out to be equal. That's how you show parametric form in the x, y, z ki jagah pe. If you plug in the coordinates, if all lambdas come out to be the same, that means the point lies on the line. And if in one value the parameter is different, then the point does not lie on the line. So, यहाँ पे in this question we have to show that the two lines L1 and L2 are parallel, which means we have to show that this is happening. If this is happening, then one fixed point on one line cannot lie on the other line. Which means if I were to show that point A, if I were to plug in point A into the parametric equation of line L2, I will not get the same value of mu throughout. It will show that point A does not lie on the other line, and hence both lines are separately parallel. See, the direction vectors are parallel that we've already shown. So it's not the case where they are non-parallel, they might intersect. That's not the case at all. The only thing now we need to distinguish is, are they separately running parallel, which we actually, when we say parallel, this is what we mean, or are they overlapping? So, the next step what you need to do is take one of the fixed points of any one of the equations and plug it into the other one and show that it does not lie on the other equation. So let's say we convert line L2 to the parametric form. So that would be x equals 1 minus 2 mu, y equals 4 mu, and z equals 1 minus 2 z. Yeah.
But we already prove that they are parallel by that.
Their direction vectors are parallel. When the examiner says, are these two lines parallel? So he means separately running parallel, not overlapping. The two direction vectors being parallel can be for both the cases. See, there's a direction vector here of this line, and there's a direction vector here of this line. They both are parallel. And let's say this is your line L1, its direction vector is like this, and line L2, which is overlapping, has direction vector. Aren't these two parallel? So it could be any one of these two cases. We need to show it's that one, separately parallel.
So both these lines are the same equation then L1 and L2. If they have a common point A.
They don't have a common point here. ये तो show कर रहे हैं.
Like isn't A on both the lines like?
This is the. बाद में discuss करेंगे. Hold on to your question. I'll discuss this later. Okay. So now what are we showing? That point A does not lie on line L2. Okay. So how do we show that? We take the coordinates of 0, 3, and 2 and plug it. Right? Let's do that. And let's see. You should not get the same value of same value of mu throughout. 0, 3, 2, right? See, I don't even need to check the third equation. These two equations are giving me two different values of mu.
सो अगर इक्वल हो गए जैसे तो सेम होगी ठीक है ओवरलैपिंग हो जाएगी
Equal क्या होगा?
अगर सेम वैल्यूज आएंगी
That means the point is common to both lines, which means both the equations are representing the same line. The lines are not parallel. So, we got the lines, we got the mu value different, which means A does not lie on the other line, which means this is the case, this is not the one. Therefore, we say line L2 is parallel to line L1 is parallel to line L1. So, this is your step 1. This is your step 2. Convert one equation to the parametric and plug one fixed point into the other one. This is your step 3. Three steps. Are we good? Any questions? Shall we move on? Okay, next case is non-parallel. Alright, so very simple, if the direction vectors are not parallel, then the lines are non-parallel. That's as simple as that. But when you have non-parallel lines, because we are dealing with 3D, we're not dealing with 2D anymore. In case of 2D, what used to happen was, because we were dealing with one plane and both the lines were on the same plane, so if they were not parallel, they were supposed to intersect at a common point. But in 3D, if two lines are not parallel, that does not mean that they will definitely intersect. Two lines can be in different planes and they can be non-parallel and still not intersect. Those lines which are not parallel and still do not intersect are called skewed lines. Now, this is what I am discussing over here. If the direction vectors are not parallel, then it's one of the following cases. Either the lines are intersecting at a common point or the lines are not intersecting, in which case they are said to be skewed. Now, how do you tell the difference? That the lines are intersecting or are they not intersecting? You tell the difference by starting off with the two equations and trying to solve them simultaneously. We assume they are intersecting, we will try to solve them simultaneously and try to find a common point intersection. If we are unable to find a common point intersection, that would show that they are not intersecting. And if we are able to find a common point intersection, which means clearly they are intersecting, and hence we would further find the point intersection as well. So this is the procedure. Solve the parametric equations with the two lines. So basically you need to convert both equations into the parametric form and then solve the two equations simultaneously. We know how, when we solve two equations simultaneously, what are we trying to get? We are always trying to get the point of intersection. So this is the same thing that we're going to do here. If it results in a common solution, then lines are intersecting, else they don't intersect. So let's try question 10. And I'll tell you how to solve parametric simultaneously. Okay, so first thing is, पहले तो दोनों को parametric form में बनाओ. First,
we can just.
the first thing which basically what you should do is you should show that the direction vectors are not parallel. एक statement लिखना है बस सिर्फ. So your equation basically for the first one is this. 0 minus 3 minus 2 plus lambda times 2
0 1
0
1
1, yeah. And the other equation is 1
minus 5
2 minus 5 plus mu times 1 minus 1, 2. So just mention this, that 201 is not any scalar multiple of 1 minus 1, 2. Clearly. So they are not intersect. They are not parallel. This should be your first step. अब हम आगे बढ़ते हैं. To show, do they intersect or they do not intersect? So we will attempt to solve both equations simultaneously. और end में result ये होना चाहिए कि we are unable to find a common solution because we need to show they do not intersect.
So the value of lambda will be different for each
So
of
देखो ना. Okay, convert both the equations to the parametric form. So I guess it should be something like this.
सर सीधा आर से रिप्लेसमेंट करना है
सिंपल होता मैं कर चुका हूँ.
500 वही होगी
नहीं बात नहीं. करो ना पहले पूरा बात समझ. Okay, so are these the two parametric forms? Are we okay with it? Now how do you solve these two parametric forms simultaneously? What you do is, see, solving simultaneously means you saying that they both equations are equal. That's the whole idea of solving simultaneously. So when you're saying that, that would mean that this x is equal to this x. If you're trying to solve them simultaneously, this y is equal to this y, and this z is equal to this z. This is what it means then if you're solving them simultaneously. So what you do is you pick these two equations, equate them, and pick these two and equate them. We'll get two equations in terms of lambda and mu. Leave out the third one, just take them. So this would give you 2 lambda equals 1 plus mu, and this one would give you minus 3 equals 2 minus mu. Two equations in terms of lambda and mu, solve them simultaneously, get me the value of lambda and mu from these two equations. I think mu the concept clear. So mu is coming out to be
lambda
5 and lambda is 3. Check. Okay. So this is what we get. Mu is 5 and lambda is 3, which is making the two x's equal and which is making the two y's equal. And if there is a common point of solution, common point of intersection, then this lambda and mu should make the two z's also equal. If this lambda and mu is not making the two z's equal, what does that mean? That means the lines are not intersecting. That's how you show.
So that's
Which has to be shown through all three equations. So this lambda and mu, once you get, should be further plugged. It should be plugged into the two equations. This mu should go here and this lambda should go here. If it gives you the same value of z, the two lines are intersecting at a common point. If it does not give you the same value of z, both the lines are not intersecting at a common point. Yeah, and that's what we have to show. So the z that you're getting from here is 1, and the z that you're getting from here is a 5. The z's are not equal, therefore lines do not intersect. Clear? That's the procedure.
आगे
Okay, in question 11, we need to show that the two lines are intersecting. And once we show that, then you also have to give the position vector of the point of intersection. So the procedure is the same. So, clearly 1 minus 1 minus 3 is not a scalar multiple of, that's the first step. What's the second step? Convert the two equations to the parametric form. Then what's the third step? We equate the x equations and the y equations. This would give us lambda is 2. This would give us minus lambda is 1 plus 3, which means mu is mu is minus 1. Now lambda is 2 and mu is minus 1. These values of lambda and mu should give you the same z from both equations. That's what we need to show, that the lines intersect. So when you plug these, so the z value that you get by plugging in lambda
minus 5
is minus 5, and the z from here also is minus 5. Hence, the lines intersect. Now we have just shown that the lines intersect. We need to give the point of intersection, position vector for the point of intersection as well. So you already have the z value with you. You just need x and y now. So either you can plug in the lambda here or you plug in the mu here, you will get the same value of x and y. So I guess the point of intersection is coming out to be 2 minus 2 minus 5. Check. Plug the lambda here, or you can plug the mu here, you get the same x and y. But the question is not asked you for the point of intersection, by the way. The question is asked you for the position vector of the point of intersection. So don't give the answer in this form. You need to give the answer in the position vector form. So you can say this is the point P, point of intersection. So the position vector is 2 minus 2 minus 5. Are we all good till here? Any questions? Is everyone okay with the procedure? Last question of the day. Now see in this question, the question has already told you that the lines are intersecting. They're not asking you to show that they intersect. They're giving you the information that the lines do intersect. Yeah, so keeping that in mind, now how do you find the value P? So the procedure is the same. Get the parametric equations. यहाँ पे step 1 करने की जरूरत नहीं है because we're not showing it. We directly come down to the procedure, convert both the equations to the parametric form, solve them simultaneously, the x and the y equations, to get the value of s and t, and use it in the third one, and you would already know that it should give you the same value z, which will give you the missing value p. P is in the z position, by the way. The first equation, second equation should be 1 plus 2
Yeah, 3
minus 4 plus pt.
Check it out. P and unknown.
P is the one that you need to find out. So first you get the value of P and S from the first equations, and then use it in the third one.
इसकी वैल्यू
So t is minus 4.
S
S is minus
equals
S minus
1 minus 0 is 7. So S equals
Minus 3.
and T equals
Minus 4.
Okay. So when you plug them here,
P is 0.
you should get the same values. So we already know that they should be equal. So minus 1 minus T is 0. So we got the value phi, and now we need to find the point intersection as well.
So all x, y, z. All x, y, z.
All x, y, z. Now whether you plug T here or you plug S here, you get the same x, y, z. Minus 3.
7 minus 1. Minus 4.
Minus 3, 7, minus 4 should be the point intersection. Guys, any questions? Are you all good?